Hello everyone, welcome to the ITLS Academy. Today we are going to discuss the topic that is your determination of chloride, and the method that we are going to use is a potentiometric method. Okay, so previous some other methods that we are already discussed, and the topic related to this video related to this topic are already uploaded. That is the determination of the chloride by using a ferry oxide method. Okay, and also we completed the determination of the chloride by the arginometric method. Okay, so here we are going to discuss about the determination of this chloride by using a potentiometric method. So let's start the today's lecture. The first one is your introduction. We all know that we already discussed many times this introduction slide here. The chlorides are present in a natural water. They can be attributed to a dissolution of the salt deposit, discharge of the effluents from a chemical industry, oil well operation, and a seawater intrusion in a coastal areas. They are what? They are the sources of the chloride into a natural water. They are not chloride. Uh, Presence of the chloride into a natural water are either come from a salt deposit, discharge of effluents from a chemical industry, oil well operation, and seawater intrusion in a coastal areas. Each of these sources may result in a contamination of both type of the water. Either they are a surface water or either they are a groundwater. Okay, so these sources that is your salt deposit, discharge of effluents from chemical industry, oil well operation, and seawater intrusion in a coastal areas. They are what? They are the sources of the chloride into a natural water, and they will contaminate both type of the water, either surface water or either groundwater. The salty taste produced by the chloride are totally depend upon the chemical composition of the water, because we all know that this chloride are produces the salty taste. Okay, but the salty taste are produces into a water due to the composition of that water. Because suppose that if the concentration of the chloride is around 250 milligram per ml, okay, but it give a salty taste. Why it give a salty taste? Because of the presence of the sodium ion into it. Okay, if the sodium ion are present, then it will give a salty taste even at a small concentration. Okay, but suppose that if there is the concentration of this chloride is around 1000 milligram per ml, but the salty taste are absent due to the predomination of the calcium and the magnesium ion into a sodium ion. Okay, high chloride content may also harm a pipe and structure as well as agricultural plant. That's why it is very important to determine the chloride concentration into a water. Principle: chloride is determined by a potentiometric titration silver titrate solution. Okay, here the method that we are going to use is a potentiometric method, and it is determined by a potentiometric titration silver nitrate solution with a glass and silver chloride electrode system. During the titration, an electronic voltmeters are used so that it will detect any change which occur in a potential between the two electrode. Okay, so voltmeter can detect it. And the end point of the titration is that instrument reading at which the greatest changes in the voltage has occurred. For a small and constant increment of a silver nitrate will be added. This is the principle of this experiment. Now the next is your here introduction is completed, principle is completed. Now the next is your iodide and bromide are also titrated as a chloride. Okay, that means that this iodide and bromide are present into our sources and it will interfere into the reaction, because when the titration are occur, then it will also titrate along with the chloride. Ferricyanide causes a high result and it can be removed. Chromate and dichromate interfere and should be reduced to a chromic state or removed. Okay, so chromate and dichromate are also present into a sample and maybe it will interfere into the reaction. So it should be removed to a chromic state, or it should reduces into a chromic state, or it should be removed. Ferric ion interfere if present in an amount substantially higher than the amount of the chloride. Okay, if the ferric ion are present more than the chloride ion into a sample, then it will interfere into the reaction. Chromic ion, ferrous ion, phosphate do not interfere. Grossly contaminated sample usually required a pre-treatment where the contamination is minor. Some contaminant can be destroyed simply by adding a nitric acid. Now the next is your apparatus used for this experiment. We required a glass and silver chloride electrode. The first apparatus that we required is a glass and silver chloride electrode. Prepare in a laboratory or purchase a silver electrode which is coated with a silver chloride for use with a specified instrument. Instruction on use and care of electrode are supplied by the manufacturer. The next apparatus that we required is a electronic voltmeter to measure a potential difference between the electrodes. Okay, so we required a electronic voltmeter so that it will measure a potential difference between the electrode, a pH meter that converted to this use by substituting the appropriate electrode. And the next apparatus that we required is a mechanical stirrer with a plastic coated or a glass impeller. Reagent that we required, the first reagent that we required is a standard sodium chloride solution and its molarity will be 0.014 molar. So for that, first of all, we required a sodium chloride. We required a sodium chloride, and the sodium chloride are already dried at 140 degrees Celsius and for 2 hours. Okay, so we dissolve around 8. So we have a, this is your beaker. Into beaker, first of all, we are going to add a 824.0 milligram of already dried sodium chloride, and then we dilute it with 100 ml of distilled water. Okay, then we required our nitric acid solution HNO3 in a concentrated form. Then we required a standard silver nitrate titrate. So for that we required a silver nitrates, the 2.395 gram, and it will be dissolved into a 1000 ml of distilled water. Or you can say that first of all you have to dissolve this silver nitrate into a 500 ml of distilled water. Then when all the silver nitrate are dissolved, then you have to make up a volume of 1000 ml. Pre-treatment reagent that we required is a sulfuric acid, hydrogen peroxide 30%, sodium hydroxide 1 normal. Procedure. The first is your standardization. The various instruments that can be used in this determination differ in operating detail. So you have to follow a manufacturer instruction, make necessary mechanical adjustment, Then allow a sufficient time for warm up. That is, you have to at least give a 10 minute for the warm up. Then balance a internal electrical component so that it will give an instrument setting of 0 millimolt. Or if the pH meter is used, then the range of the pH should be around 7. Now you have to place around 10 ml of standard solution into a 250 ml of beaker. That means that first of all you have to take a 250 ml of beaker. Now into it you have to transfer a 10 ml of standard sodium chloride solution. Then you have to dilute it at 100 ml. Then you have to add a 2 ml of concentrated HNO3. Then immerse stirrer and electrode. Then set an instrument Now set an instrument to a desired range so that millivolt or pH unit start stirrer. Now you have to add a standard AgNO titrate and record a scale reading after each addition. At the start, large increment of AgNO3, that is your may be added, and then as the endpoint is approached, add a smaller and equal increment, that is around 0.1 or 0.2 ml at a longer interval, so that the exact endpoint can be determined. Determine the volume of AgNO3 which is used at the point at which there is a greatest change in instrument reading per unit addition of this AgNO3 take place. Now the next is you have to plot a differential titration curve if the exact endpoint cannot be determined by the inspecting the data. Now you have to also plot a change in instrument reading for a equal increment of silver nitrate against a volume of silver nitrate added by using a average of burette reading before and after each addition. Sample analysis. Pipe it 100 ml of sample or a portion which contain not more than 10 milligram of chlorine into a 250 ml of beaker in the absence of all the interfering substance. Okay, so how you remove all the interfering substance? By using the reagent that we already discussed in a previous slide. Now, in the presence of organic compound, sulfide or other interference, that is your large amount of ferric cyanide or sulfide, acidify the sample with the help of the concentrated sulfuric acid by using a litmus paper. Okay, boil it for a 5 minutes so that it will remove all the volatile compound. Okay, again you have to add more sulfuric acid if it is required so that the solution become acidic. Now you have also add 3 ml of H2O2, that is hydrogen peroxide, and boil it for a 15 minute. Then adding a chloride free distilled water so that the volume become above than 50 ml. Then dilute it to 100 ml and add a sodium hydroxide solution so that dropwise until alkaline to a litmus paper. Then you have to add 10 drop in excess and boil it for a 5 minute and filter it into a beaker and wash precipitate paper several times with a hot distilled water. Now add concentrated HNO3 dropwise until acidic to a litmus paper. Then add 2 ml in excess. Okay, when you get acidic in a litmus paper, then you have to add 2 ml excess. Now cool and dilute to 100 ml if it is necessary. Then immerse a stirrer and the electrode and start the stirrer. Make any necessary adjustment according to the manufacturer instruction and set a selector switch to a appropriate setting for measuring the difference of potential between a electrode. Complete determination by titrating accordingly. If an endpoint reading has been established from the previous determination for similar sample and condition, use this predetermined endpoint for the most accurate work. Make a blank titration by carrying a chloride-free distilled water through the procedure. Now the formula: milligram of calcium per liter is equal to A minus B multiplied by N multiplied by 35450 divided by ml sample. So where A is equal to uh, silver nitrate in ml, B is equal to blank, N is equal to normality of the titrant. When you put all the values into the formula, you will get the amount of calcium in milligram present in per liter of sample. So this is all about the determination of this chloride by using a potentiometry method. I hope you will understand, but if you have any query related to this topic, you can ask me in a comment box, or for a further detail, you can follow the ITLS Academy on different platforms, that is Instagram, Facebook, Twitter, YouTube, WhatsApp, LinkedIn, and subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. Or you can also ask your query to the helpline number that are already mentioned in your slide, that is 7080833450, and visit our website www.itlsacademy.com. Thank you for watching. Please like, share and subscribe our channel.